So right now, this is in case you're unable to access the simulation on your computer or tablet. So if so, I'm just going to be demonstrating some different things that you can be doing, and you can make some observations and conclusions based on what you are observing. So I'm going to go right to the run. So first, I have an object that isn't moving, so I am going to try applying a force in this direction. When I apply a force, I'm going to notice that it starts moving. So I'm wondering whether or not the direction of the force mattered. Did it matter that I hit it left? Would the same thing happen if I tried hitting it right? So I can see right now that it really seems as if the direction of the force isn't having an effect. It's really if I'm adding a force on an object that's not moving, that it is going to start moving. So that is right now my first observation, is that if force is needed to have an object start moving, but the direction doesn't matter. So having an object that is already moving, I'm going to see if I can have what happens if I add an additional force. So when I add an additional force, that object started to speed up. But I'm wondering if it always happens. If I always have an object moving and I do an additional force, does that always make the object speed up? So here I have it speeding up, but now what if I add another force? The object didn't keep speeding up. So that kind of wonders the question. So what was going to cause an object to either speed up or slow down seems that that really has to do with the direction of the force. So here I've prepared that I'm going to have a 20 Newton force on this object. And I'm wondering if I'm hitting it in the opposite direction, what is going to happen to that object? So now hitting it to the right, I'm noticing that the object is slowing down. And what if I hit it again? So now I've hit it twice on both sides, and I can see that the object stopped. So I can make some conclusions right now about how the direction of the force is going to either make it slow down or make it speed up or make it stop. And it seems that it has to do with not only the direction of the force, but also the size of the force. So resetting, I'm really curious if I'm having a 20 size force going this way, what's going to happen if I then add a 30 size force? So now I can observe that right now the object actually has changed directions. And then if I hit another way, hit it again, it's going to now speed up. So in this example, we so far have been able to have an object start moving, stop moving, change direction, speed up, and slow down. So while you're answering those questions, if you rewatch this video, you'll be able to think about why did this happen based on the direction of the forces and the size of the forces.